So let's talk a little bit about trigonometry on a unit circle. What is a unit circle? Well, a unit circle, of course, we have a circle with a radius of 1, and in plane geometry, the equation for that circle would be x squared plus y squared equals 1. And that's actually a very simple thing to derive for us, right? We would say that if we were to look at a right triangle that's formed by taking the origin to some random point xy somewhere on this unit circle, we already know that we're talking about a shape with a radius of 1. And so if we look at the x and y values that go with it, well, here's x and here's y. And of course, because it is a right triangle, x squared plus y squared would equal 1 squared by the Pythagorean theorem. Well, a couple little points about this unit triangle that we've just come up with within our unit circle. First of all, what would be the circumference? Well, if you remember, circumference is equal to 2 times pi times the radius, r. And if the radius is equal to 1, then our circumference will equal 2 pi. And that's an important point because we can say that we actually look at this circle in terms of its entire circumference from 0 all the way around to 2 pi. And another point about that, well, half of a rotation then would be pi. Whatever units we're talking about, right? If this is 1 inch as a radius, then 2 pi inches all the way around. Pi inches, which is 3.14 inches to here. Half of that, pi over 2 inches to this point way up here at the top. Right? The arc length t is subtended by a central angle theta. What is the relationship between t and theta? Well, okay, what do we mean by that? Here's a quick question. Arc length t. So, all right, we find some arc length here then. So the arc length is simply a distance around the edge of the circle until we get a point. So let's call that arc length t. What could we say then about the relationship between t and theta? Well, interestingly enough, if we use the entire circle as our arc length, then that arc length would be exactly equal to the circumference. By the same token, if we just went around half of the circle, our arc length would be exactly equal to pi. And it turns out that if our arc length, by the relationship s equals r theta, if we use t as the arc length and a radius of 1, then t is equal to theta. And that's important because now we can say, well, if there is an inner central angle theta, it will correspond exactly to the arc length t along the outer edge of the circle. And this is a fact that we can use to help us define our other trigonometric functions. So if we imagine that we start trying to take sine and cosine and tangent, etc., of the arc length t, it corresponds exactly to our arc length, to our central angle theta. And since we're on a unit circle and t is equal to theta, then we can say some of the following definitions right here. Here's the value of x, here's the value of y, here's 1. Sine of t, being the ratio of opposite to hypotenuse, is equal to y. Cosine of t, being the ratio of adjacent to hypotenuse, is equal to x. Tangent of t, being the ratio of opposite to adjacent, is y divided by x. Cosecant of t, being the reciprocal of sine, is 1 over y. Secant of t, being the reciprocal of cosine of t, is equal to 1 over x. And finally, cotangent of t, being the ratio of adjacent to opposite, is equal to x over y. And that's really, really useful because if we can find any coordinate point on the plane that corresponds to some arc length t, then we can express all of our trigonometric functions in terms of that angle. So let's say here we are again We have our arc length t as defined by the standard position starting at the point 1, 0, all the way to the point negative 8 seventeenths, 15 seventeenths, which is here in quadrant 2. And we're interested in finding the values of the 6 trigonometric functions of the arc length t that correspond to that point. Well, in this case then, for this arc length t, we could say that the sine of that arc length t is equal to the y coordinate 15 seventeenths. Cosine of that arc length t is equal to the x coordinate right here. So we take our x coordinate, negative 8 over 17ths, and that gives us our cosine of the angle. How about tangent? Well, tangent, very simply, is equal to y over x. So if I take 15 18ths, 15 17ths, if I'm paying attention, and divide that by negative 8 17ths, well, then my tangent of t will be equal to the ratio negative 15 eighths. Now I can continue like this. If I take the cosecant of t, I'm taking the reciprocal of my sine, so my cosecant value would be 17 fifteenths. Cosine has a reciprocal of secant of t, and in this case that's going to be negative 17 over 8, negative 17 eighths. And of course the cotangent of t is our reciprocal of tangent, so the cotangent of t will be negative 8 over 15 this time. Well, that's what we were looking for, so we're off to a good start.